Okay, we are recording. Okay, this is Durwood King with Samson Community College, and this is ELC 118 National Electric Code, and it is Tuesday, August 31st. And today we're going to start in chapter 2 in the book, and we're going to try to cover Article 200 and 210 today. Now, chapter 2 contains other articles. It contains Article 210 through 242. We'll try to cover 2 today, 2 Thursday, and so on. And this is going to go on into next week as well. The chapter 2 is pretty big chapter. For those of you watching the recording, for today, there will be a worksheet, and it's only 11 questions. I'm going to give you a hard copy that's got like 50 questions on it, and that's going to cover all of chapter 2. So you only need to do the 11 of those in Moodle. There's only 11 in this particular assignment, and you can submit it and it'll grade itself. I'll do those in segments for whatever articles that we're covering. This is the way I'm creating the worksheets in Moodle, is by whatever we're covering that day. So you can do them in segments, but the hard copy is going to have everything for all these articles, so you can be having you a paper copy of that. So anyway, that's it for those of you watching the video. That will be the assignment for today. The hard copy, I'll give you one if you like it. But again, there's a total of 50 questions in this that covers all the articles. Now, you just work on the 11. And then as we go through it, you'll eventually go all 50. Between now and say sometime next week. Yes, sir. Miss you this morning, honey.
Yeah, I had to go ahead and
Anybody coming in? All right, let's click on our PowerPoint.
for the ACBC guy for the home model 2.2. If you want us to resubmit the answers and remove it.
No, the paper copy is all you gotta do for here. There's so much you got to write in there.
Yeah,
For anybody that's at home and can't come, that's the only people need to do that particular one to submit it online. Yep. Okay, so here we go. Hey, hey, you come on in. There's your hard copy for the next section. The next worksheet is only, it's going to cover the first 11 in there. For what we're trying to cover today, Article 200 and 210. And then we'll cover 2 more articles Thursday, and then the chapter 2 has got a lot of articles, and it's going to take us probably close to 2 weeks to cover all of it. And I'm looking at doing a test next Thursday, not this Thursday, but the next one for Article 90, 100, and 110. So try to get your 90, 100, and 110 submitted so you can see the results. And then you just, if you can jot down your results on your hard copies, and you got something to study by. So let me make a note of that. I just gave it y'all. Did not give you one? How about there? I missed y'all that.
Is that under the book I had out already?
Yeah, I thought, yeah, I was thinking you had one. I'm glad you did that. I'm gonna make a note up here. I know everybody's got a lot of classes. Well, some of y'all have a lot of classes that you're doing. It's hard to remember about things that coming up. So I'll try to remember to put test dates up here. And we'll need to work in like a little pop quiz on chapter from Article 90 to 110. A little small pop quiz, like 10 questions. I was going to try to do that Thursday this week or maybe Tuesday next week. One or the other to do a little pop quiz. It will cover 90 to 110. Like 10 questions. And it comes straight off your worksheets. There's nothing other than what will be on the worksheets. So if you've done them, then you already know the answer. You know what I mean? You know, I'm thinking from those. So here, ELC 118. Test. Articles 90, 100, 110. Thursday. September 9. Okay, everybody see here? September 9 is when we're looking at doing the test on Article 90 through 110 test. It'll be like 20 questions. I'm not going to make them big because we got so much to go. You know, so I'll think about 20 questions out of these. You know, 20, 25. No, I'm just going to say probably 20 questions. Because we got to keep moving with it. If I give you a really big test, it's going to take up the whole class period. You know, there's so many articles to cover. Okay. So anyway, so here we go. Chapter 2, wiring and protection. There's a lot of good stuff in the chapter. It looks at general rules for wiring and sizing services, feeders, branch circuits, and for overcurrent protection of conductors, wires, as well as the proper grounding and bonding of electrical circuits and systems. It applies to all electrical installations covered by the code book, except anything that may be modified in chapter 5, 6, and 7. Those are the specialty chapters, like for healthcare facilities, gas stations, and things like that that are not general purpose installations. These are the articles that's contained in chapter 2. 200 through 250. Yep, I missed a while ago when I was on page 101. You flip over one more page, and Article 250 is the last article within chapter 2. It's on grounding and bonding. Now, ideally, it would have been good if you had residential wiring or commercial wiring before you had this class, in my opinion. But they didn't have the prerequisites required, so you were allowed to get in if you didn't have those. So it's if you have any difficulty understanding the terms that we're using, let me know and I'll stop and try to explain. And just know that as you take more electrical classes, actually using the stuff and doing it, wiring and using devices, these terms are going to make more sense. In my opinion, this class should be in your second year of your electrical system degree, because you really need some time to know what the devices are and some time to use the stuff. So it covers using and identifying neutrals and grounded phase conductors, branch circuits, feeders, service calculations, outside feeders, services, over current protection, over voltage protection, grounding and bonding. That's a lot. You know, it's going to take us about 2 weeks just to hit the high spots on this stuff. So Article 200, it covers, we start out with the identification of grounded conductors, like neutral wires, for instance, or other grounded conductors and their terminals. There's two types of grounded conductors. You have neutral conductors, and then you have sometimes they'll actually ground the phase conductor. That's done in some cases, as you'll see in some of the diagrams. So in this one, there's 4 different examples of how conductors are grounded, applications of it. The first one is showing a single phase 3-wire system here, and it's showing a transformer that has the center tap grounded. It's a neutral wire that brings a neutral current back to the transformer, and it's also grounded. So that's one method of grounding conductors, or grounded conductors, rather. Here you have a different type of a transformer, a wire wound transformer. And this may be something brand new to you you've never seen, and it's okay if it is. It's just showing you some examples. If you haven't had any electrical classes before this, you're going to get into this stuff in other classes as far as knowing the uses of it. So that is a wire wound transformer with the center part of the wire grounded. The neutral wire is at the center point too, that brings neutral current back to the transformer from those hots. The hots carry current out to some load, and then it comes back on the neutral to the center, and then it ends up going to ground. This is a kind of a situation you don't run into very often. It's a delta type transformer. These transformers are transformers that are outside the building that feed a building like this. So out there in the yard, in those large green transformers that are in the yard, they can be delta wound that's feeding us, or it can be delta, which is like a triangle. That's delta wound or wire wound. And it could be one or the other that's out there in the yard that feeds the building that where we get our power from the power company outside. So you're looking at wiring that would be feeding this building, a transformer that's feeding us from outside. In some cases, it's kind of rare, but you can have a delta transformer outside feeding your building, and it may have something like called a high leg, and that's something that you get into in commercial wiring if you take that. Where one of your phase wires from phase to neutral would be a higher voltage than the other two. There's three phase power there, but one of them, the orange one, would be a higher voltage referencing to neutral than the other two would be. And that's one that you couldn't use on regular 120 volt circuits because it's higher to neutral than the other two. That's something there's not time to get into the full explanation of that now. But if you saw a Delta system feeding your building, and it had what they call a high leg, and one of them was orange, the high leg has to be color-coded orange. In other words, these other two legs might be 120 volt to neutral, and that the orange one would be some bit high enough to where you couldn't use it on a regular receptacle. So that would be one of the three that you couldn't use, and it has to be tagged in the panel. That's high leg, and you can't use that one for regular 120 circuits. But there's the example of where they send their neutral back to that transformer outside is in the center of this winding, and then they ground it. So that's a grounded phase conductor there. In the middle of that winding, they ground it, and it's also a neutral wire going back to it. Then here's one called a corner grounded Delta 3-wire system. It's Delta, it's a triangle shape, and they ground one corner of it. I've never seen that before, but it's possible that they ground one corner, use it as a neutral, and they ground it at that point. But what they're doing here is they'll put white tape on there to identify it. You got to have it identified in some manner. We're going to look at the rules on how do you identify these conductors. So if it's that particular type of a Delta with a corner conductor grounded, then they have it with white tape on there, white stripes on there. That's how you identify it. Just notice on the neutral wires, they're like black wire and they got white tape on them. That's showing the high leg there where it goes into a disconnect into a load panel, say in a building, and it has to be labeled orange. You can use all three of those for three-phase power for motors, but you can't use that single one there for regular single-phase loads. You can use the black and the blue for regular receptacles, but you can't use the orange one for receptacles because it's a higher voltage at the ground. I've never been around a system like that I'm aware of, but it does exist. The use and identification of neutral conductors. Your neutral conductor continuity. The continuity of your neutral conductor is not permitted to be dependent upon the metal enclosure, raceway, or cable armor. What they mean by that is this. It's where your main neutral is in this panel of white wire. That one should actually have a direct contact with that neutral wire that's on the load side. But in this case, they did. They ran the neutral to the ground bar. The bar is ran to the frame, and then they're depending upon the actual metal chassis of the box carried up here. And that's a violation. You can't do that. You got to have the neutral going directly to the main neutral. You can't let it go through the metal parts of the box. If you have a multiple branch circuit, multi-wire branch circuit, then you have to identify the hot wire and the neutral in some manner, either with wire numbers or in some manner that you know which neutral went with a particular hot wire. You see how they've done that? That's in the case to where they have a multi-wire branch circuit, which you get to see a diagram of what that means. see where the picture of a multi-wire is, where it really shows you. Well, a multi-wire branch circuit is where you have two hot wires feeding two different circuits in a room, but they're sharing the same neutral. They're sharing the same neutral wire. And commonly, what you would do would be to get a 2-pole breaker, like a 240-volt breaker, and you would use those two hot legs to feed two different sets of receptacles.
Well, that's what I did that the other day.
Uh,
I left the breaker box and I went to the little building and I ran 2, 4, 6 outlets off one hot lead. And then I ran 2 lights and another outlet with air conditioner on.
Off of a 2-pole breaker. That was a multi-wire circuit right there, and you were sharing the same neutral. Okay, so now, if you have multiple circuits in conduit, here they're actually using separate hots and separate neutrals here. And what they're doing is when they get over here, they do have separate neutrals here for the hots, which is actually best. They're using cable ties to group them together so that you know which neutral goes with that hot. And the same thing on this end here. They're grouping them by using wire ties. You need to have some way to identify which neutral goes with the hots. So it just needs to be in some way wire tied or either using wire numbers to show that. The next circuit is going to show you where 2 hot wires are being used with one neutral that is shared, which is something that you've got to be careful about because there's a hazard involved. If you lose a neutral connection, there's a hazard that's involved by using 2 hots on 2 separate sections with the same neutral. We'll show you what the hazard is. If you're going to use, if you got 2 different loads coming hooked to a panel, whatever those loads are, that's resistors that represent loads, like it could be motors or lights or anything, or receptacles. If you got 2 different loads and you're going to use the same neutral wire, don't use the same exact phase conductor. Don't use 2 L1s on 2 separate breakers like that. You want to use an L1 and an L2 like off of a 2-pole breaker. Get a 2-pole breaker and put it in there, and you'll get an L1 and an L2 instead of 2 L1s. If you use 2 L1s like that, then the currents are going to add and you can overheat the neutral wire. If you use an L1 and an L2, then the neutral currents you have some cancellation going on in there because of different phases, because of 2 different phases. If it's L1 and L2, and you won't overheat the neutral wire. You would have to go out of your way. You would actually have to skip a breaker to do it.
It's not only for single phase stuff.
Right.
For 3 phases, you have to like skip for the deep.
If it's a 3-phase panel, it would be L1, 2, 3, and then 1, 2, 3. It goes in 3s like you see there.
Something like that.
Well, if it was a 3-phase panel, you could use L1 and 2, or just any 2 of the 3. As long as it's just 2 different phases that you're picking. Yes. Yeah. As long as it doesn't have a high leg. Yeah. Right. So this is what you don't want to do. You don't want to use the same exact phase leg for both of those loads when you're using one neutral. The actual best way is to use 2 neutrals. Just pulling out the wires is the best thing.
Sometimes trying to save the 100 wire.
Yeah, right. What they're saying is that the return current back from the loads, it's additive. Those currents are going to add up and you may overheat that wire, the neutral wire. Those of you that are taking the ELC 112, you know what happened whenever you tried to put, when you put a hot and a neutral within a current clamp and the reads cancel out, you got 0 amps. They're talking about in here that if you use a L1 and a L2, that those currents, once they get on the neutral wire, that there'll be a cancellation effect in there to some extent. And so that the neutral current will actually show up being less because of a cancellation effect in that neutral going back. It's a different kind of cancellation, but it's the same idea in a sense when you use two different phases here, but the same neutral wire. When those currents get back in that neutral wire, the neutral wire doesn't see an additive effect like it does here. Just sort of take their word at that. Now this is how you identify grounded conductors like neutral wires if it's a 6 AWG or smaller. That wire can be white in color, it can be gray in color, it can be any color but green with 3 white stripes or gray stripes, and it can be white or gray with stripes, any color but green. There, you just simply put white tape on it. If it's a grounded conductor like a neutral, you just put white tape on it. Well, here it says it's not permitted. The tape is not permitted if it's below a 6 AWG. You can have white or gray wire. You can have three stripes, 3 white stripes. The neutral can't walk. I didn't say it one more time.
The neutral can't be white or gray, or it can't be black if it's under 6.
If it's under 6, exactly. Yeah. Right. Now, if you go the next size up from a 6 AWG, the numbers get smaller. So the next bigger wire would be a number 4. And so you're allowed for these identification means for a 4 AWG or bigger. You can have white finish or gray finish on the wire. You can have white or gray stripes on any color but green, and you're allowed to put white tape on these that are 4 AWG or bigger. Then you can put the white tape on those. If it's a neutral wire. So that sort of sums it up there for 4 AWG and bigger. You know, the white, the gray, or the white or gray stripes, or the tape, the white tape. Neutral conductors of different systems. They must be individually identified by white or gray outer finish along the entire length. So if you have in a box like that, if you have 120 volt and then a 277 volt, which is used on some fluorescent lights, then it's good to use a white on the 120 and use gray from neutral on the 277. And then they're using the wire ties also. Two different voltages that are in that same box. The 277 is going straight on through. The 120 is put to the receptacle. Now, if you've got like Romex cable for residential, they do allow you to use a white wire for a hot wire if you re-identify it, say with tape like red tape, for instance. Those of you that had residential, if you did the switch leg, remember doing that switch loop, then you know that you were able to use, or maybe to a water heater, for instance. You were able to use a white wire for hot by putting black or red tape on it.
The three-way switch.
Yeah, even on three-way switch, you can use a white wire as a hot if you identify it with a red tape or black tape. If you hadn't had residential or commercial, then you'll actually do this in that class whenever you wire. How many of you taking residential now? Okay, then you've got a class, you've got a lab coming up in there to where you'll use this method in there. Yeah, white wires will actually be hot in some cases. That's an example of it right there of a switch leg. In this example, the breaker panel is actually feeding from the breaker panel up to the light fixture first. So the power is being distributed in the attic overhead. And they do that on hog farms and all that. That power is overhead, then it'll go down. So the power is coming into here to the light fixture first. They're taking that black wire to hot wire from the breaker. They're attaching it to a re-identified white wire, which is with red tape. So the wire that's constantly hot comes down this cable. That's regular residential cable, regular NN cable, the sheath cable. It's coming down that white wire with red tape. And look at here. That white wire that's actually hot goes into the switch. That's a regular single pole switch. It goes into the switch here with a white re-identified red. It leaves on black. The ground wire is on the strap, but look here. You go in with this white one, this red stripe. It leaves on the black when it goes back up. That's why they call it a switch leg or switch loop. The hot wire comes down, it goes in the switch, and it goes right back up the loop. Goes back up the black. The black goes to the actual brass screw for the bulb, and the neutral that came from the breaker panel goes straight to the light. See that? So that's what you call a switch loop when you're distributing power from overhead. It's not coming in through the walls or under, but it's an overhead thing. So it's going to come. It'll go to your box for your light fixture first, and then it'll come down to the switch and then go back up like a loop. or a switch leg. So that's an example of where you can use a white wire for a hot, you know. Because for one thing, a neutral is not needed in that box. Nothing in that box needs a neutral, so you're allowed to use the neutral as a hot feeding in to the switch. That's just another example of the same thing, where the power went to a box. It went up. Well, that's slightly different there. For three-way or four-way switch travelers, there you've got three-way switching there. You've got 2 locations of switches for 1 light. That's about, how many of you have done that so far in residential? Have you done three-way switching yet? You have done it, so you've already done that. Okay, yeah. There's a violation where they don't allow using a white wire for hot if it's in conduit. If you're putting single stranded wire and not the Romex cable, you know, not flat Romex cable, but regular single stranded wire. So here you got conduit and you don't have Romex wire in and not a cable, but it's individual wires. They don't allow you to use a white as a hot in that case there. So it has to be it's got to be that type of cable, not conduit. So you know, when you go to conduit, things change. They figure there's no point in you having it if it's a white cord. You should be a full different color wire, you know what I mean? So with a cable, you don't have you've only got what you got. Identifying the terminals, you know, like neutral terminals are going to be silver. On your receptacles and your receptacles, they will be silver. Or it has to be identified by the letter W. It may be done that way on range receptacles, like for others. Like these big range receptacles or for dryers, it may say W and instead of it being a silver terminal. Or the word white. They're showing there where on light fixtures, your neutral wires are, your neutral terminals are silver there. And they are connected to the threads. Like what we were saying the other day, your neutral is connected to the threads. And then your hot wire is connected to the tip. You know, whenever y'all check the resistance of a bulb, you're checking for the threads to the tip. The threads are neutral, and then the tip is the hot wire. And that's Article 200. We can click on the 210. I can show a little bit of that. We don't have a couple minutes, I know, but let's do what we can of it. Article 210. It's on branch circuits. And again, if you have any trouble finding any of the answers in here, let me know and I can tell you what page any of it's on. I can give you a quick reference to get to it to help you along with this.
I didn't realize that it was actually which bank it was
Well, see, I started putting it in there. I started putting it in there this time. As you get in there further, I started put page numbers in there on this new one.
That saves the time right there.
On this new one. You'll notice that on this new worksheet, I put page numbers in there for you. Because there is a lot in there, and it's a very short amount of time. I even took article numbers, I got about halfway down through the worksheet, I put page numbers and article numbers in there, that you can get right straight to it. So for branch circuits, Article 210 covers your requirements for that, about conductor sizes, overcurrent protection, identifying GFCI and arc fault, as well as receptacle outlets and lighting requirements. By definition, a branch circuit ends where the load is connected, and it starts at the breaker itself. So when you say branch circuit, it's like looking at a tree. You got a tree trunk and you got branches. The tree trunk could be, say, the breaker panel, and then what feeds out of the panel on individual breakers would be the branches, like, you know what I'm saying, like branches of a tree. That's basically all it is. This is an individual branch circuit that starts at the breaker panel itself, leaving that breaker, and it ends at the load. And what they call a feeder would be what feeds in from your service outside, feeds into your panel inside. That would be your feeder. It's giving you article numbers for different things like air conditioning and refrigeration and so forth, heating equipment and so forth. All of you conductors from a multi-wire branch circuit must originate from the same panel board. Now, there's a good example right there, Luke, of a multi-wire branch circuit like you were talking about. This is an example of it, where you have a two-pole breaker. You got a 240-volt breaker there, and they're using each individual leg for 120 purposes. So the first hot leg, the black one, if you measure from that black to neutral, it's going to read 120. If you read from black to red with a meter, it's going to read 240, but they're not using 240-volt loads on this. They're using 120 volt off of this with a neutral. And that one hot wire goes to these two receptacles, and they're using the same neutral here. They're also using for these receptacles, it's using a red hot wire off of the other part of that breaker. This is actually a multi-wire branch circuit that's using two hots and one neutral. Okay, so this is a true picture of what that means. Again, this shows the measurements from as far as a voltmeter. If you put a voltmeter across those, you would read 240 across those, but you would read 120 from each one in neutral. That would be the voltage readings you would get. But if you notice, you're not putting a black and a red on anything out here, so none of these loads are 240-volt loads. They're all 120-volt loads. A branch circuit with two or more phase conductors having a voltage between them, but they have an equal voltage between each one and neutral. That's a true multi-wire branch circuit. Now, when you're doing multi-wire branch circuit, both of the hots, they got to be to where they'll disconnect at the same time. If something goes wrong, it needs to cut both hot legs at the same time, like this. Here, you've got a multi-wire branch circuit. You're coming off of a two-pole breaker, and you got one neutral, and you're feeding a red hot there and a black hot there, and one neutral. But look, if something, because they're sharing the same neutral, they want it so that if something goes wrong, it's going to trip the breaker and kill both legs. So that it will actually, there'll be no neutral current there if something goes wrong on one of the circuits. It's gonna, you don't want one of them to trip and still have neutral current there. You know what I mean? You got to knock it both hots out so that there's no neutral current coming back at all if there's a problem on one of those circuits. So the 2-pole breaker takes care of that. Internally, if one leg draws too much, the whole thing's going to trip and it's going to kill both legs. That makes sense? If you use 2 individual breakers, you can use a handle type, something that just slides on there. You can buy a handle type with two single poles and slide it on there. And then if one trips, it makes the other trip. It's supposed to. I don't like it. Because they don't always force the other one to trip you for the handle type. I've seen the case where it did.
That's better than nothing. That's better than nothing.
Better than nothing, yeah. You can use a 2-pole. You can use 1-pole breakers with an identified handle tie. If you slide the handle tie across there, hopefully it's going to be strong enough to make the other one trip if one trips. That's just a standard, like a dryer or oven receptacle there that you're feeding from a 2-pole breaker. That's just normal, a 240-volt load there. They're just showing there how they're grouping neutrals and hots together. We'll stop at this point right here. It's going to take a little bit more to explain that. And it is 5 till 2 anyway. It's time to stop. So we're going to stop our I can start at the other one at 2 o'clock. We'll pick up from here Thursday. But you can start and do what you can of those 11 questions. There's only 11 questions in there, and but there's a lot of stuff in 210. There's a lot of things, so we'll put more time. It's going to take more time to get through 210 for sure. Yeah. So we're going to continue 210 on Thursday. Okay. Yeah. It's a bigger article. The timing of each thing as I plan it is going to be adjusted as we go through, because it's the first time I've taught the class, and I honestly don't know how long it's going to take to cover each article, really. So do what now? More than an hour, you can believe that. Yep. But again, you'll notice in the worksheet in Moodle that I put page references in there this time. I have. In this new worksheet, and that's what I plan on doing from here on out to help you save you some time. Yeah. Yeah. Hey, how y'all doing? Okay, whoever's watching recording, we're wrapping it up, and we'll see you Thursday. Whoever's watching by video, you have a nice evening.